Can you show the homework by turning on the back camera or with the help of front camera?
Yes, sir. 1 minute.
Yeah. Sahu, what about you?
Sir, is it visible? I am showing.
It's not visible, Sahu. It's completely dark.
Sir, now?
Still the same.
So may I send you the photo after the class?
Okay, but Vedika, just reverse your notes. Okay, I written the lanthanides and everything. Okay, good. Sorry, not metals, non-metals, everything you wrote. Any doubts in yesterday's topic? What we discussed yesterday?
No, sir. No doubts.
Combined state, free state, noble elements, the physical properties of metals and non-metals. So we finished up to oxides. We are okay. So any doubts in the formation of oxide? We stop it till here itself, right?
Yes, sir.
Okay, 1 minute. Reactivity series, displacement reaction. And actually we have done the description comparison between the metals and non-metals also. You can see
Yes,
the table,
sir.
tabular column here also. Have you gone through this book, complete
But
book?
now we need to start with the chemical properties, I think.
Yeah. 1 minute.
So we have started the chemical properties.
So in the chemical properties, we started with the formation of oxide, right?
Yes, sir.
Okay. So whenever the metal react with the oxygen present in the air, it will form the metal oxide. These metal oxides are what nature?
Basic in nature.
Basic in nature. Good. So if you take any metal and react with the oxygen, it will form metal oxide. And metal oxides are generally basic. Basic in nature means they are the bases. Suppose if the base dissolve in the water, that is called as an alkali. Clear up to this?
Yes, sir.
Yes, sir, clear.
If the base dissolve in the water, that is called as an alkali. Okay.
Yes,
But
sir, okay.
all the alkalis are bases or not? All the alkalis
Yes, sir,
are
they are.
bases? Yeah. Then what about all the bases are alkalis?
No, sir, they are not.
They are not alkalis, right? Okay.
Yes,
so
sir.
listen here carefully. When metal react with the oxygen, it will form the metal oxides. Metal oxides are two types. One is a basic in nature, the other one is a amphoteric in nature. How many types? Two types. One
Two
is
types.
a basic in nature, the other one is a amphoteric in nature. Basic in nature we discussed already. If you dissolve in the water, it will form alkali. Then what is the meaning of amphoteric nature? What's the meaning of amphoteric nature?
Sir, they react with both the acids and the alkalis.
Amphoteric oxide means oxide which show both the acidic properties as well as the basic property. Amphoteric oxide means what? Oxide which will show both acidic property as well as the basic property. That is called as an amphoteric oxides. Suppose if you take, can I write it here itself? Can you see?
Yes, sir.
1 minute. Okay. What is the meaning of amphoteric? The oxide which shows both acidic properties as well as basic property. That is called as an amphoteric oxides. Okay, that means it can react with the both acid as well as the base. Suppose if you take ZnO, zinc oxide, Al2O3, aluminum oxide, these are amphoteric in nature. That means they will react with both acid as well as the base. Understanding?
Yes, sir.
Acid which reacts with the both acid as well as the base are called as an amphoteric oxides. Examples are the zinc oxide, aluminum oxide. Other example PbO2 and the
Lead
SnO2,
oxide
lead oxide and the tin
and
oxides.
tin oxide.
These are the amphoteric oxide which react with the both acid as well as the base.
Sir, are there only these or many more?
These are the some common examples. There are some more oxides will be there that is not required completely, but these are the most common examples we'll use. Okay.
Okay, sir.
Now we said basic oxide, right? Metal oxides. Metal oxides are basic in nature. In basic in nature, whether they will react with another base again. I said initially metal oxides are basic in nature, right?
No, sir.
That means they are basic in nature. Again, they will not react with another base, right? Compulsory they require the acid only. Yes or no?
Yes, sir.
Then only it will become acid plus base, neutral salt plus water. It will form like this. Okay. So metal oxides are how many types?
2 types.
One is the basic oxides. Next one is the amphoteric oxides. Basic oxide means which will combine only with the acids. Amphoteric means it can combine with the acid or the base.
As well as space.
Any doubts in this?
No, sir, no doubts.
Take the screenshot of this and you can copy. If you're writing the running notes, it's good. Okay, can I erase the part? Whatever the written I have written here.
Yes, sir.
Yes, sir.
One minute. So that is all about the formation of oxides. Sorry. The next one is the example. You know litmus paper, right?
Yes, sir.
So if you take the basic nature, in the case of basic solutions, litmus paper converts the red color litmus paper to blue color litmus paper. So here what is taken now? Magnesium reacting with the oxygen, it will form magnesium oxide. So again, magnesium oxide dissolved in the water, now that is alkali. So it will form magnesium hydroxide. So magnesium hydroxide is a basic substance. Basic substance. Okay. So magnesium hydroxide is a basic substance. So how the basis will show the color of the litmus paper? It will convert the
Blue.
Blue.
red litmus paper to the blue color. So you can see one experiment also here. That is only explained in this diagram. Whenever the metal oxides are dissolved in the water, it will convert the litmus paper from red color to the blue color. Okay. The next one. Everyone knows about the rusting of iron. Yes or no? What is the meaning of rusting of iron?
Sir, oxidation or corrosion of iron.
Oxidation or
Corrosion.
corrosion of iron. Okay. Can you tell me the equation part?
4Fe plus 3O2 plus XH2O is 2Fe2O3 XH2O.
Okay, very good. So corrosion if is there, whenever the iron reacting with the water vapor present in the air along with the oxygen present in the air will form the iron oxide Fe2O3 2H2O. There is the equation for the corrosion. 4Fe plus 3H2O plus. How many oxygens?
3O2.
3O2 gives rise to 2 Fe2O3 to H2O. Okay. So this is a corrosion process. So 2H2 only required. So this is a complete corrosion equation. But for the corrosion purpose, what is the important conditions are required? One is the water, the other one is the oxygen. Okay. So corrosion means iron reacts with the water vapor and the oxygen present in the air to form iron oxide. That is only the rust. Iron oxide only the rust, which is what is the color of the rust here?
Reddish brown.
Reddish brown. Okay. So there is a corrosion in the case of iron. But in the case of copper also, there is a green color coating will develop on the copper. If you take copper,
Copper oxide.
there will be green color coating will develop on the copper. It is not because of copper oxide. Listen carefully. Whenever the copper reacting with the water vapor, oxygen, carbon dioxide present in the air. What are those? Whenever the copper reacting with the oxygen, water vapor, and the carbon dioxide present in the air to form copper carbonate
COOH whole.
and copper hydroxide. What is the compound it will form? Copper carbonate and the copper hydroxide. This will only show the green color coating on the copper. It will show the green color coating on the copper. Understanding? So what is the important condition for the copper to get the green color coating?
Oxygen, carbon dioxide, water.
Oxygen, carbon dioxide and the water. So whenever the copper reacting with the oxygen, carbon dioxide and the water, it will develop the copper carbonate and copper hydroxide. These will form the green color coating on the copper. Okay, suppose if you want to remove the green color coating and to get back the original color of the copper, what you have to do?
So lemon, we can rub
Why-
on copper.
Why you want to use only lemon?
Sir, because that is basic in nature, so it will neutralize after rubbing lemon.
Very good. Here the copper hydroxide is there, right? Which is basic in nature. So if you take the any acid, like lemon will contain the citric acid, right? So if you take any edible acids or the normal acids, and if you apply on the surface of the copper,
Sir, that means we can take anything like tomato, apple, then vinegar.
yeah, vinegar also can take.
Okay,
Or
sir.
lemon. Okay, vinegar also you can take and you can wash it. You want some acidic substance to remove that green color coating. So when you apply the acidic substance on the copper vessels, it will go and react with the base present in the green color coating, and the green color coating will be vanished off. So that we will get the again fresh look for the copper vessels. Understanding?
Yes, sir.
Clear
Yes,
up to
sir.
this?
Yes, sir.
Are any doubts?
No doubt, sir.
Similarly, if you take the silver, if you use the silver jewelry, after some days, the silver jewelry will get the black color coating, right?
Yes, sir.
Why? Because silver will react
Sir,
with the,
because of reacting with water.
not with the water, reacting with the hydrogen sulfate present in the air.
Sir, it is a pollutant, right?
Yeah. Whenever the silver react with the sulfur present in the air, it will form Ag2S. That is a silver sulfide. Silver
Sulfide.
sulfide. What is the compound here? Ag2S. So it is literally black in color. Whenever the silver react with the sulfur present in the air, it will form Ag2S. That is called as silver sulfide, which is black in color. Okay, that is a black color coating on the silver articles. In the case of copper, green color coating. In the case of iron,
Reddish brown color
reddish
coating.
brown color coating. Then how to prevent the rusting of iron?
Sir, by oil painting, by greasing.
By painting or
Galvanization.
by galvanization. Very good. What is the meaning of galvanization?
Sir, the coating of iron with magnesium.
Not with magnesium. the coating on the surface of the iron articles with the help of one suitable metal. What is it? It is very important galvanization process. What is that, Vedika?
Sir, applying a layer of zinc on the iron.
Very good. So coating of the zinc metal on the surface of the iron articles is called as an galvanization. Galvanization means what? Applying the zinc metal on the surface of iron articles. Which metal?
Zinc.
Zinc
Zinc.
metal. Other methods also there. What is it? Electroplating.
Painting.
Electroplating, or we can say third one. What is the third one? Galvanization, electroplating, painting, or oiling of chains, greasing. You can use all these methods. Okay. Take the screenshot of this also and you can copy it afterwards in the classwork notes. Take the screenshot.
Done, sir.
Finish.
Yes, sir.
What about other?
So finished.
Okay. If I write like this, no problem, right?
No problem, sir.
Okay. Again, I'm gonna erase all these things only. Again, that's problematic. So next we'll study about the reactivity series. So I will give you one shortcut trick so that you can remember easily. So here some error is there in the reactivity series. Okay, don't follow this one. I will give you the correct series, reactivity series. There is a trick. Please stop calling me a careless zebra. Instead, learn how copper saves gold. How copper saves gold, platinum. So there is a complete reactivity series. Listen here carefully. First, lithium will come here. Okay, leave that lithium. Next, P for potassium. What's the P? Potassium. S for sodium. C for calcium. M for magnesium. A for aluminium. Okay. And C for carbon. Can you see here? This pen.
Yes, sir.
So C for carbon. Z for zinc. I for iron. L for lead. Here hydrogen, copper, silver, gold, and platinum. This is a complete reactivity series. So what is the reactivity series? What is the first element?
Sir,
Potassium.
Lithium, lithium. Lithium, potassium, sodium, calcium, magnesium, aluminium, carbon, zinc. What is the next one? Iron. Next, lead, hydrogen, copper, silver, gold, platinum. Understand? These are the elements in the reactivity series. So
Sir, gold is less reactive than platinum, right?
no. Gold is more reactive than platinum only.
Okay, sir.
Okay. So as you go from top to bottom, the reactivity series. This is also continuous only, right? As you go from top to bottom in the reactivity series, the reactivity will increase or decrease?
Decrease.
Reactivity will decrease. That means if you take any particular element, suppose which one is the most reactive here?
Lithium.
Less reactive elements, the last. So lithium is the most reactive element and platinum is the least reactive element. Okay. So as we go from top to bottom, reactivity will decrease. But main important thing in the reactivity series is, suppose if you take sodium, sodium can have a more reactive than the calcium, magnesium, aluminum, copper, zinc, and all. But sodium is more reactive than potassium and lithium.
No, sir, less reactive.
Compared to the potassium and lithium, sodium is less reactive. But compared to calcium, magnesium, and all the below elements, sodium is more reactive. Clear?
Yes, sir.
Like this. So if you take reactivity series completely, if you take any particular element, that particular element cannot replace the above elements or cannot displace the above elements, but that particular element can displace the below elements. Understanding?
Yes, sir.
Now tell me whether magnesium is more reactive or calcium is more reactive.
Calcium.
Calcium is more reactive. Then magnesium can replace the calcium,
No, sir. Calcium can replace magnesium.
but calcium can replace the magnesium. Very good. Now, hydrogen is more reactive or the gold is more reactive?
Hydrogen.
Hydrogen is more reactive. So hydrogen can displace the gold?
Yes, sir.
Yes or no?
Yes, sir.
Understand, Sahu? Sahu, are you
Yes,
there?
sir.
Any doubts in the reactivity series?
No, sir. Sir, but our teacher taught us a little different one, this acronym for learning all these.
Which one?
What, sir?
Sorry, can you repeat again?
Nothing, sir, nothing.
You're saying something different order and all. No problem, you can repeat what is there.
No, sir, nothing.
Okay. So this is the correct order only. Please stop calling me a careless zebra. There's a shortcut trick, one mnemonic. Please stop calling me a careless zebra. Instead learn how copper saves gold. So if you remember this mnemonic now, you can remember or you can write all the elements in the reactivity series. It's very important also. Okay. And
Yes, sir.
whatever the elements are there in the starting of the series are the most reactive elements. That means they can lose the electron easily, right? These are the most reactive elements. That means they can lose the electron easily. Then what about the last elements? These are the least reactive elements, so they cannot lose the electron easily. Understanding? So starting elements can form the electropositive nature easily. Yes or no? If they lose the electron means it will form the electropositive nature. So starting elements in the reactivity series can form the electropositive nature easily. Any doubts?
No, sir. Sir, so the less reactive metal will form electronegative.
No, metals will not form the electronegative at all because metals always have tendency to lose the electron only, right? They don't have the tendency to gain the electrons.
Sir, so what about the less reactive metals?
They will also lose the electrons at the higher temperatures. But compared to lithium, sodium, potassium, they will not lose easily. Understanding?
Yes, sir.
Suppose if you take Cu, copper, copper also will lose the electron only, plus 1 electron or plus 2 electrons. But it cannot lose the electron easily, immediately. It will take some time
Yes,
to
sir.
lose the electron. But if you take sodium now, it is ready to lose the electron always.
Okay, sir.
The starting elements are always ready to lose the electrons, always ready to donate the electrons. But whatever the last elements are there, they are not at all ready to lose the electrons immediately. That is the difference. Okay.
Okay, sir.
So can I erase this right side blue color part?
Yes, sir.
Now what is the displacement reaction?
Sir, when the most reactive metal displaces the less reactive metal.
Very good. It is a chemical reaction in which most reactive metal will displace the least reactive metal. Now I will write some chemical reactions. You have to tell me which one is correct and which one is wrong. Sure. FeSO4 plus Cu. Reaction is possible, this one? You have to tell me the answers. First one. What is the answer for first one?
Sir, first one is possible.
Possible. Check it properly.
Sir, not possible.
Sir, how do we find if it is possible or not?
Sir, because iron is in reaction with that sulfate and iron cannot be displaced by copper.
Very good. I will explain you. Listen, Vedika. What is the displacement reaction definition? The most reactive metal will displace the least reactive metal from its compound. Okay.
Yes, sir.
The most reactive metal always in the elemental state. Elemental means element format. Okay. One will be in the elemental format. The other one will be in the compound format. So if you take copper and the iron, which one is the more reactive?
Iron.
Iron is more reactive. So copper cannot replace the iron from the sulfate, right?
Yes, sir. Got it.
So it is reaction will not happen at all. But if you take AgNO3 and Na,
Sir, second one is possible.
sodium is more reactive than the silver. So sodium will
Yes,
replace
it
the,
will replace Ag and form NaNO3.
it will form NaNO3. Just you take simple. Instead of writing Ag, write the NaNO3. Plus what will form? Ag will form. Okay.
Sir, third one is
Sir,
not
so,
possible.
Check it, third one.
sir, so if we have a mixture of AgNO3 and if we mix sodium in that, can we obtain pure silver?
Yeah, pure silver will get very good. One more point you added here. So in this case of reactions, if you want to extract the pure metals, we'll add the higher reactive metals, right? So that we can extract the pure form of Ag here
Yes, sir.
from its compound.
Yes.
Okay, what about the next one? Third
Sir,
reaction.
not possible.
So possible?
Then I should say it is possible, not possible only.
Sir, because Fe is more reactive than Cu, so yes, sir, that's possible.
Yes, sir. FeSO4 will be formed and Cu will be released.
FeSO4 is formed and Cu will be
Released.
released. Understand or not?
Yes, sir.
Sir, understood.
Fe is more reactive than Cu, right?
Yes, sir.
So it will form FeSO4 plus Cu. Now one more important will come from this only. Do you know blue vitriol? The color of copper sulfate
Yes,
is
sir,
blue.
CuSO4.
The color of copper sulfate is blue vitriol. That is a blue color. Okay. So FeSO4 is a green color. Green color. Understand? Hello.
Yes, sir.
So FeSO4 is a green color. CuSO4 is a blue color. Blue vitriol. We call this as a blue vitriol. We'll call this as a green vitriol.
Understood, sir.
It is very important. I'll explain it with the diagram only. Okay. This one. Last equation part. But the reactivity series, any doubts are there?
No, sir, no doubts.
Sahu? समझ गया नहीं? साहू,
Yes, sir.
आप भी हिंदी वाला है ना?
What, sir?
You know Hindi, right?
Yes, sir, I know.
Okay, okay. What about Vedika?
What, sir?
You know Hindi?
Yes, sir.
Okay. Any doubts in this?
No, sir, no doubts.
Okay. Take the screenshot of this. You can copy it in or afterwards. Okay.
Done, sir.
I'm going to clear all the things. Finish, Sahu.
Yes, sir.
Okay. Now can you see one diagram here?
Yes, sir.
So instead of this, I will open one more textbook. Please wait. In that it will be clear. See, I am telling you this chapter with the 8th class syllabus, as well as I'm including the 10th class also. Again, the same chapter, metals and non-metals, are there in the 10th class also. Okay. So combining both the chapters, I'm telling you.
Okay, sir.
So whenever anybody asks you questions from the metals and non-metals, you should be ready to answer all the questions from this chapter. Are you ready?
Yes, sir.
Yes.
Whatever the question it is, you should be able to answer. That is only the motive. Okay. Now can you see the diagram here?
Yes, sir.
One minute. क्या हुआ? Suppose you have taken the copper sulfate solution in first test tube. Okay. So you have taken the copper sulfate solution in the first test tube. Generally, you have discussed that copper sulfate is a blue color. Now we will take one iron nail. You will take one iron nail. Okay. Generally, you take like iron like it's a white in color, but I have drawn with the red color, right? So when you take the iron nail and keep it in this surface, what will happen? The iron will react with the copper sulfate. Okay.
Yes, sir, and will displace copper from an CuSO4.
So what is going to happen? CuSO4 plus iron nail. Iron nail in the
Fe.
it will form.
FeSO4 plus CO.
Okay. Now the solution color will change, right? It is initially blue color.
Yes, sir.
Now it is changing into the green color. You can see the color change from here to here.
Yes, sir.
Yes, sir.
Now where this copper will go and deposit? The copper will deposit on the iron nail here. Can you see here? Initially the iron nail is white in color, but after the chemical reaction, what is happening? The pure form of the copper will
Brownish.
deposit on the surface of the iron.
Yes, sir.
Okay. So iron nail taken out from the copper sulfate solution looks like this color. Now it is clear.
Yes, sir. Yes, sir.
This is a class 10th textbook itself.
Sir, then where does that FeSO4 go? Is that solution of FeSO4?
Yeah, this part is there, right? That is the FeSO4 solution. That is a green color.
Okay, sir. And on the iron nail, the copper gets deposited.
Yeah, iron nail, copper get deposited.
Okay, sir. Understood.
So based upon the reactivity series only, you can say whether the reaction is possible or not. Clear?
Yes, sir. Clear.
Yes, sir.
Take the screenshot of this also.
Done, sir.
So here also explaining the same diagram only, okay? One minute. Yeah. So zinc displacing iron from the iron sulfate solution. Zinc is more reactive or iron is more reactive? Hmm?
Sir, zinc.
Sir, zinc.
Sorry. So now what is happening here? Copper sulfate solution is there, magnesium they have taken. What will happen? Whether magnesium can displace the copper from the copper sulfate?
Yes, sir, it can displace.
So only on the magnesium surface the copper is coated, right?
Yes, sir.
Okay. Okay, before going this, we have one more small part is left here. Did you study it like sodium is very reactive with the water or oxygen before?
Yes, sir, it is explosive.
Okay, tell me what is the reason behind that?
Sir, because sodium is one of the highest reactive metals in the reactivity series.
Okay. See, if you take the lithium, sodium, potassium, right? Next one is a calcium, magnesium, aluminum, zinc, iron, like this. If you take series elements now, the starting elements are very reactive. That means even with a small amount of water or the oxygen, they will release large amount of heat. Okay, understanding? Whenever the sodium or the potassium contact with a small amount of water or the oxygen present in the air, it will release a large amount of heat only along with the hydrogen gas. If you take sodium and dissolve in the water, what will happen? Sodium is more reactive than the hydrogen. Yes or no? So it will form Na2O plus, it will release the H2. Along with these two, it will release the heat energy also. Okay, this heat energy is very high, and we know H2 is a flammable gas. Flammable means what? Which will start burning only in the presence of heat. Yes or no?
Yes, sir.
So whatever the heat energy produced will use it to